Ecological disturbances are also a major cause of the spread of infectious disease. The first we'll talk about is deforestation. Almost half of the Earth's forests are no longer in existence or have been severely damaged, possibly to the point of no return. This is a result of agriculture, human settlement, logging, and mining over the past 8,000 years. Deforestation is a major factor in the eruption of emerging and re-emerging infectious diseases. Wilderness habitats serve as reservoirs for a large variety of insects and other animals that harbor infectious agents. Reservoirs are locations where diseases can lie and hide away from the human population for extensive periods of time. In many cases, this is where diseases are naturally found. There are many cases of these ecological disturbances and deforestation leading to the spread of infectious disease in the human population. One of these fairly recently is valley fever that has been reported of construction workers, particularly in southwestern United States, including parts of California. Human intrusion into the environment also fosters contact with wildlife and insects, and plays a major role in the migration of these displaced species into villages, communities, and backyards. A great example of this is the rise of rabies in the eastern part of the United States as a result of raccoons infected by the rabies virus foraging for food in garbage cans in suburban and rural communities. Chagas disease is another one of these important diseases that may become more prevalent in the United States. It's a protozoan disease that's carried by beetles, commonly called kissing bugs. They're called kissing bugs because they tend to bite on the face and lips of the individual or the person. In the early 1900s, construction of the Central Railroad in Brazil was undertaken through a heavily forested tropical wilderness. Eventually, these beetles ended up biting and infecting humans and their domesticated animals, including some rodents as well. This led to the spread of Chagas disease and has led to thousands of people becoming infected in the last 100 years, with many deaths. As a result of climate change, which we're going to talk about in a moment, we're starting to see these very same kissing bugs spread north into the United States. The US used to be too cold for this particular biological vector, but now with climate change, the kissing bug is starting to spread to Southern California, New Mexico, Arizona, and Texas. And we may see Chagas disease come with it. In 1998 and 1999, a new and deadly virus named the Nipah virus killed more than 100 people in Malaysia after showing up on a pig farm. This disease was new, an emerging disease, and not known to humans before. But it was infecting a very large type of bat known as the fruit bat. Bats ate dates from palm trees and left their saliva behind that was full of the Nipah viruses. When people started developing pig farms in these areas, the dates that fell from the trees that were half eaten from the fruit bats were also contaminated with that fruit bat saliva and the Nipah virus. The pigs then were infected with the Nipah virus, and then, of course, in turn, infected people, showing the complex interactions that we have in ecosystems in the world today. Another complex interaction was demonstrated in Egypt's billion-dollar Aswan High Dam, a 10-year project that was completed in 1970. It harnessed and controlled the Nile River and created a lake that was subsequently referred to as Lake Nasser. The walls of the dam served as new and convenient habitat for snails, and the snails, in turn, were important hosts for a parasitic worm known as a schistosome. The schistosomes, these parasitic worms, grow inside the snails, and then when a person swims in the fresh water that's contaminated by these snails, those worms can leave the snails and enter the human body, causing schistosomiasis. In addition, other problems of infectious diseases concerns arose as a result of the Aswan High Dam, including Rift Valley fever. Different from valley fever that we talked about in the United States, Rift Valley fever is transmitted by mosquitoes. And being transmitted by mosquitoes, having a dam that traps and holds water can lead to increased pools that accumulate in the desert, leading to an increase in mosquito populations, which can also increase the spread of Rift Valley fever. This particular disease led to 200,000 people becoming infected and more than 500 deaths. Finally, most scientists agree that the HIV virus is a result of the spread of disease from simians, or monkeys, to the human population. Perhaps sometime at the turn of the 20th century, humans living in close proximity to monkeys would hunt and kill and eat these monkeys, otherwise known as bushmeat. In the process of doing this, one of those monkeys infected with simian immunodeficiency virus, or SIV, probably infected a hunter who accidentally cut himself, perhaps as he was either killing his prey or chopping up the meat for dinner. This cut in his hand probably led for the transmission of simian immunodeficiency virus, or SIV, into humans. And in this particular case, this virus had a mutation that allowed it to infect people. Once it infected people, it became more adapted and evolved to be able to spread from person to person more readily. And over the next 50 or 60 years, very likely evolved to be able to spread from person to person in a way that made it easier to transmit in parts of Africa and then from there around the world, leading to today's HIV, or human immunodeficiency virus, which is similar to, but substantially different from SIV, or simian immunodeficiency virus. Again, it was human intrusion into ecosystems that allowed for the transmission of diseases in animals to be spread to people. These are otherwise known as zoonoses. Climate change is another ecological disturbance that can lead to an increase in disease transmission. As you can see from this chart, Table 4.3 and Table 4.4 in your book, there are many different diseases that are implicated in climate change, and that as the planet warms, we would likely see an increase in these various diseases. The primary reason for that is because many of these diseases are transmitted by vectors that thrive in warmer climates. Insects such as mosquitoes, ticks, and sandflies require warmer temperatures in order to survive. This is because insects are exotherms, or cold-blooded organisms, and cannot survive in colder temperatures. In fact, for thousands of years, humans have relied on winter to kill off many of these insect populations, and that allows us to alleviate the risk of infectious disease in the winter months. However, with increasing temperatures, those winter months tend to get warmer, and with warmer seasons, we're going to see an increase in mosquito populations, tick populations, sandflies, and others. Also, in some areas around the world, we're seeing an increase in rain and humidity as a result of climate change. This increase in rain and humidity can also increase the risk of waterborne diseases, such as cholera, cryptosporidosis, and leptosporidosis. In fact, we've already seen climate change lead to an increase in some of these diseases already. One of these cases is with malaria in parts of Africa, including Ethiopia and Madagascar. In parts of Ethiopia and Madagascar, people have intentionally set up large towns and sometimes even cities at higher elevations in order to escape the warm climate where mosquitoes thrive. However, with climate change on these mountain regions, the winter months are warmer and mosquito populations can thrive year-round, leading to an increase in mosquito-borne diseases, including malaria. This was also seen in the northwest frontier province of Pakistan, where winter is usually so cold it kills mosquito populations. But unfortunately, as a result of climate change, we're starting to see the winter months in Pakistan be warmer, allowing for the increase in mosquito populations, leading from a few hundred cases of malaria to more than 25,000 in less than 10 years. We're also seeing an increase in malaria, tick-borne encephalitis, and leishmaniasis in Italy. Again, an area that normally wasn't affected by these populations year-round, but where we're starting to see this increase as a result of climate change. And as I mentioned earlier, Chagas disease, spread by the kissing bug, may eventually find its way to the United States. Hantavirus in the US has already seen an increase as a result of climate change. Hantavirus, normally found in warmer climates such as New Mexico, Utah, Colorado, and Arizona, is not usually very common because in those areas there's not a lot of plant life. And without a lot of plant life in those desert areas, the rodent populations don't have a lot of food and cannot grow to very high numbers. But with increased climate change, we're starting to see more humidity and rainfall in these areas, leading to an increase in plant growth. With more super blooms and increased plant growth, there's an increase in rodent populations which can spread things such as hantavirus, which is extremely deadly. In the next section, we're going to talk a little bit more about ecological disturbances as they pertain to natural disasters, and then get into some other factors that affect transmission of infectious disease, such as microbial evolution and adaptation, technological advances, and human behavior.